Revolutionary GPU programming language unveiled. Ready to witness the future of GPU programming? Join us at AI Mastery Collective as we reveal Bend, an innovative language from higher-order Kyo. This tool makes GPU programming easier than ever, bringing high-performance computing to everyone. Don't miss out. Watch now. Revolutionary GPU programming language unveiled. GPU programming. To get why Bend is special, we need to first dive into GPU programming. Let's see what is GPU. GPUs, or graphics processing units, are chips made to speed up how images and videos show up on screens. But GPUs are also great for doing many tasks at once, which is perfect for things like scientific research, data crunching, and machine learning. Traditional GPU programming can be tough. You usually need to know languages like CUDA and OpenCL, which require a deep understanding of how memory works and how to manage many tasks at once. This complexity can be a hurdle for many developers. Bend aims to simplify this by offering a high-level, easy-to-use language that hides much of the difficult parts, making GPU programming more user-friendly. Let's look at the features of Bend. Easy-to-use syntax. There are many of features in Bend, but from all those, a standout feature of Bend is its easy syntax. This makes it possible for developers to write GPU-boosted code without diving into the complexities of CUDA or OpenCL. For example, with Bend, using the parallel GPU command in a loop tells the GPU to handle the loop. This command spreads the work across all available GPU cores, making the coding process much simpler. This simplicity is similar to other parallel programming languages like Chapel and Futhark, which also aim to make writing efficient parallel code easier. Bend is unique because it specifically tunes for GPU performance, making it a powerful tool for developers. High-level patterns for simple coding. Bend offers high-level patterns for common parallel programming tasks. These include operations like map, reduce, and scan, which are key for many computations. By focusing on these high-level operations, Bend lets developers think more about the logic of their programs rather than the nitty-gritty details of parallelization. For example, the reduce function in Bend simplifies parallel reduction, allowing programmers to write clear and concise code. This approach not only makes coding easier, but also helps keep the codebase clean and easy to maintain. Using GPU power with ease. The real strength of Bend is its ability to tap into GPU parallelism with little effort from the programmer. GPUs are great at handling tasks where the same operation is done on many data points at once. Bend's parallel command makes this simple by splitting loop iterations across GPU cores. For example, when doing matrix operations, the parallel GPU command ensures that each element of the result is calculated in parallel. This method speeds up the process significantly compared to using a CPU, showcasing the efficiency of GPU parallelism. Performance and compatibility. Bend is made to be fast and portable. Its compiler optimizes code to run well on different GPU architectures, including those from NVIDIA and AMD. This cross-platform compatibility is crucial for developers working in various environments, from personal computers to large high-performance computing setups. Right now, Bend works on Linux and macOS. While it doesn't support Windows natively, it can run using the Windows subsystem for Linux, also known as WSL2. This flexibility makes Bend usable in different development setups, making it a versatile tool for many developers. Now it's time to compare Bend with other languages. Bend's approach to GPU programming is similar to other modern parallel programming languages, each with its own strengths. For instance, Chapel is known for its ease of use and scalability, providing elegant support for data and task parallelism. While Chapel simplifies parallel programming, Bend focuses more on GPU-specific optimizations. Another example is Futhark, a functional language designed for high-performance data parallel array programming. Futhark generates efficient parallel code for both GPUs and CPUs. Like Futhark, Bend abstracts away low-level details while ensuring high performance, making it a great choice for developers wanting to leverage GPU power. After hearing the features and comparisons, I know you are starving to use Bend, but how can you get started with Bend? Now it is the time to reveal that. To start using Bend, you need to install it on your system. particularly for Linux and macOS environments. First, install Rust nightly, as Bend relies on this version of Rust. Once Rust nightly is set up, install HVM2 and then Bend. After these installations, you can start writing and running Bend files on your system. For Windows users, since Bend doesn't natively support the platform, you can use the Windows subsystem for Linux 2, also known as WSL2, to run Bend. This workaround lets Windows users enjoy Bend's features by creating a Linux environment within Windows. Actually, we have a small surprise for you. There are advanced features in Bend. Let's delve into those as well. Bend isn't just about simple syntax and high-level patterns. It also supports advanced programming features like recursion and continuations. These tools help developers handle complex computational problems efficiently. For example, recursion allows a function to call itself, useful for breaking tasks into smaller steps. Continuations give control over the flow of a program, enabling more flexible and efficient task execution. Each and every product, software, service, language, even a word has a goal. It is same to Bend. So what is the Bend's main goal? Performance benefits. One of Bend's main goals is to provide high performance by using GPU acceleration. For instance, consider a simple task that processes a large data set. When run on a GPU using Bend, the program benefits from the GPU's ability to process data in parallel, cutting down the execution time significantly compared to a CPU implementation. These performance improvements are not just theoretical. Real-world applications have shown substantial gains, making Bend a compelling choice for developers looking to speed up their applications. Overall, Bend is a new parallel programming language that makes GPU programming easier and more accessible. Its user-friendly syntax and powerful patterns make it a valuable tool for developers, allowing them to fully utilize GPUs. Bend is more than just a new language, it's a step towards the future of computing, making GPU programming approachable and enhancing performance. As technology advances, Bend will play a key role in the future of high-performance computing. So guys, that's all about for today. Excited about Bend? Share your thoughts in the comments. If you found this helpful, like, share, and subscribe for more tech insights. Stay tuned with AI Mastery Collective for the latest in technology. Revolutionize your social media game with Akoya, where AI meets social media management. Effortlessly create, schedule, and analyze your posts across multiple platforms like a pro. Say hello to streamlined content creation and goodbye to social media stress. Try it now and unleash the power of AI at this link: https://www.okoya.com/AMC.